Welcome everybody to your video lesson about lipids, aka fats. Another important biomolecule that has many different locations where it pops up in our content this year. So let's just get right into talking about really the general structure of a lipid. A lipid is composed of two pieces, really. It's usually got some sort of glycerol head and then any number of various types of fatty acid tails. So that's what we're going to do in this video lesson here. We're going to draw a glycerol head and some fatty acid tails and just get some general ideas of how these lipids come together before we start to do some more video lessons about some specific things. Okay, so in black, I'm just going to have you draw, let's see, right here, let's do 3 carbon atoms covalently bonded to each other just like this. Okay. Now in this lesson, I'm not going to go to the trouble of drawing all the hydrogens, but I will draw covalent bonds that represent hydrogens, but just leave them empty. So there's one here, there, and sticking off the bottom down there. Okay. That makes every one of these carbon atoms have 3 covalent bonds. We should know by now that carbon wants 4, and the 4th is going to be, in all 3 of these cases, a covalent bond to a hydroxyl functional group. Okay, very good. Now, basically right across from these hydroxyl functional groups, I want you to draw some more hydroxyl functional groups. They're just going to look backwards. Okay, and we will covalently bond all of these to carbon atoms of their own. So we'll put a carbon atom there, and there. And then we'll add another functional group to these carbons. We'll let you review for yourself and see if you can remember the name of that functional group that we just drew. And then we're going to draw 4 more. 1, 2, 3, 4. 4 more covalently bonded carbon atoms off of each one of these that we already have. Okay, very good. So there you go. We just drew, let me not skip too far ahead. Let's go ahead and load all of these carbons up with hydrogens. Remember, I'm not going to draw the H's, but each one of these lines represents a covalent bond to a hydrogen atom as well. So you see that all of the covalent bonds of all of these carbon atoms are fulfilled. Okay, very good. So now all of our carbons have 4 covalent bonds in our 2 kind of different structures that we've drawn here. Now, in different colors, I'd like to kind of talk about what we just drew. This chunk of what you drew over here is known as a glycerol molecule. So we'll call this glycerol, and it really makes what's typically known as the head of a lipid. Okay, so this is the glycerol head of a lipid. And then what you've drawn over here, these like 3 identical lines, are a different part of the lipid. So we'll highlight them in a slightly different color. Okay, and these are our fatty acid, what we would call tails. And there's 3 of them. There's one right here, there's a second one here, and there's a third one right there. So really, in this image that we just drew, there are 3 fatty acid tails. Because of that number 3, and because of the glycerol head that's attached, we would call this molecule in general a tri. So that's because of the 3 glyceride. Okay, so that should make some sense. It's known as a triglyceride because it has 3 fatty acid tails, and the glyceride comes from the fact that at the head of those fatty acid tails there is a glycerol molecule. So this is an example of a very common type of lipid that has a very common structure of lipids, a glycerol head with fatty acid tails. This happens to have 3 fatty acid tails, therefore it is called a triglyceride. Now, before we say goodbye for this video lesson, you'll notice that the glycerol head and the fatty acid tails are not actually connected to each other at the moment, and that's a bit of a problem, but not one that you can't figure out, because as you well know by now, we have a very simple reaction by which we can stick various molecules together. All that we need to make is a little bit of water. So why don't we take these these hydroxyl functional groups and start picking pieces off of them. We'll get 2 hydrogen atoms and we'll get 1 oxygen atom. Okay, and let's see what happens when we do. Coming all the way down here, let's just say, let's see, for the sake of room, let's just say we just removed 3 HOHs, or 3 H2Os. So we've taken away 3 water molecules, so we've done really 3 different dehydration reactions, and what that's given us as a result, and I won't go to the trouble of drawing each individual atom anymore, but I will just show the general structure. We have our glycerol head. All right, we'll just make this nice green block. Okay, and then coming off of that glycerol head, we have 1 fatty acid tail, 2 fatty acid tails, 3 fatty acid tails. So ladies and gentlemen, there is your triglyceride. That is a general shape of what a triglyceride looks like. It is this glycerol molecule and the 3 fatty acid tails sticking off the back end, stuck together by a dehydration reaction. One last thing before we leave real quick is that each one of these fatty acid tails is basically what we would call, and you can see why for obvious purposes, a hydrocarbon chain. I guess so we can just hydrocarbon chain. Right, so if you're asking yourself what makes these fatty acids, or what's unique about them, is they are literally nothing more than a whole bunch of carbons and a whole bunch of hydrogens arranged covalently around one another. That is really the essence of these fatty acid tails. So there you have it, your glycerol molecule, your 3 fatty acid hydrocarbon chains sticking off of it. That is the general structure of most lipids, even though it doesn't necessarily always have to be 3 fatty acids. It's the glycerol plus the fatty acids making this general class of molecule known as lipids, or fats.